Okay, so the first thing that I'd like to talk about and clarify is the difference between the test statistic and the t-critical value. So the difference between the test statistic and the t-critical value. Okay, so we were talking about number 12 in the homework, more specifically chapter 10. Chapter 10, number 12, more specifically 12A, and there was a lot of 12A's on the quiz. So that's kind of what we're focusing on here. And there was two parts that was asked. The first was asking for the test statistic, and the second part was asking for the t-critical value. So let's kind of talk about what's going on there. Okay. Okay, well, let's start with what is the test statistic? Like, what exactly is that, and what is it used for? Let's take a look at this definition here, which I think is really helpful. So, we can use the test statistic and the t-critical value to determine if we can reject the null hypothesis or not. An important thing to think about here is where it says the critical value approach involves determining likely or unlikely by determining whether or not the observed test statistic, which is the test statistic that we're going to calculate, is more extreme than would be expected if the null hypothesis were true. Okay, so that's where the critical value comes in. But let's talk about the test statistic first. The test statistic is what we are going to actually calculate. It was that 2.66 whenever we calculated it before. So remember, when we calculated it, it was the test statistic is x bar minus the mean all over the standard error, or S over square root of n. Right, that is the test statistic. Now, it's important that it says observed test statistic because that helps you to understand that we are taking this test statistic from the data that was already observed. Okay, so this is something that actually happened, this observed test statistic. So when we calculate that from chapter 10, number 12, we see that the test statistic is x bar is 143 from the data, minus the mean is 136 for systolic blood pressure, all over S is said to be 24.4, and all over the square root of n, which we said n was 86. When we actually calculate that, we get 2.66. That is our test statistic. Okay, so we're trying to determine if the test statistic is more extreme than would be expected if the null hypothesis were true. So we need to compare this test statistic to something to determine if it's more extreme or not. And that's where the t-critical value come in. So the t-critical value is where we were looking before for that last page in table 8.4 in the back of the appendix A, where it gave us the percentiles of the t-distribution. Okay, so we want to be using that. Specifically, for the problem that we're focusing on, we had 86 as our n, so our degrees of freedom. The degrees of freedom, remember, is n minus 1, so the degrees of freedom here would be 86 minus 1, or 85. Okay? So, looking at this, now we can use the degrees of freedom and alpha, which is our level of significance here. And it said that alpha for this specific problem was 0.1. So alpha for this specific problem was 0.1. Okay, that's our significance level. And if we split that into 2 on both sides, that's 5% on each side, because the significance level is 10%. If the significance level is 10%, that means this is a 90% confidence interval. Because remember, the confidence interval is 1 minus alpha times 100%. That's how we get the confidence interval. So if our alpha is 5%, If the alpha is 5%, then we have a 95% confidence interval. So splitting it in two and going in the back of the book, we can see that at a degrees of freedom of 85 and at 5% on each side, our critical value is 1.663. This is saying that if the null hypothesis were true, this is what our test statistic should be about if the null hypothesis were true. So, looking back in the definition right here, if the test statistic is more extreme than the critical value, then the null hypothesis is rejected in favor of the alternative. So when we are comparing these two things, we are comparing the test statistic of 2.66 to the t-critical value of 1.663. And we can obviously see here that this is greater than our critical value. So the critical value is what is expected if the null hypothesis were true. Okay, since our test statistic is greater than that, we reject the null. So, we could also calculate a p-value and compare that to the significance level if we wanted to, okay? However, we can just see from these two things, the test statistic and the t-critical value, that because the test statistic is more extreme than what is to be expected, we can reject the null hypothesis in favor of the alternative. That does not mean that we can conclude that the null hypothesis is false or blah, 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 or whatever. We can't say it's true. All we can say is that we have enough evidence to reject the null hypothesis in favor of the alternative because of this. Okay. Another thing to keep in mind here, these are the 4 steps that we basically just went over. However, step 4 says compare the test statistic to the critical value, which we just did. If the test statistic is more extreme in the direction of the alternative, okay, so that's really important to keep in mind. For this specific example, more extreme is greater than the t-critical value. In this case, it was. That's why we rejected. So just keep in mind that the direction of the alternative is important. Okay, if we're doing a one-sided or whatever, just keep in mind the direction of the alternative. Okay. Reject the null hypothesis in favor of the alternative. If the test statistic is less extreme than the critical value, do not reject. Okay, so this is comparing the test statistic to the t-critical value. Okay, so in this specific example that we were looking at, the test statistic was 2.66. Write that. And the t-critical value was 1.663. This was found using the degrees of freedom and alpha, the level of significance. Okay, this was found using this specific formula up here for the test statistic. Okay, once we found both, found that the test statistic was more extreme, thus we rejected the null.